All right, so check this out. In this inequality, what we're going to do is we're trying to isolate the variable x. So what I'm going to do first is I'm going to eliminate this term, the 3 here. So I'm going to make a 0 pair by doing the opposite of what I see here. So consider this to be something like 3 positives. Opposite of 3 positives is 3 negatives. And what I do to one side of the inequality, I'm going to do the same thing to the other side. So I got to put 3 negatives on the other side. So that way my solution set is true to whatever this inequality is. In other words, whatever you do when you solve equations, you got to do the same thing to both sides, so that it stays balanced. Same idea applies to inequalities as well. So now what I do is I'm going to simplify in the next step. I'm going to bring down my inequality sign. 3 positives and 3 negatives, that's a 0 pair, right? They come out to be 0. And we're left with the term x. And here, 4 minus 3, I can see that that is just 1. So that's my solution. X is less than 1. In other words, all numbers less than 1 will be a solution to this inequality here. Now I'm going to go ahead and graph this. So I'm going to do a quick sketch. I'll put the number, the endpoint in the middle. And I'll put a couple numbers after, a couple numbers before. And you can see here that it's saying all numbers less than 1. So on a graph, to say we're not including the 1, because it has to be less, not equal to, but less. So what I do is I'll put an open dot to say we're not including that number. And numbers less than 1 would be to the left. So in a number line, numbers always decrease going to the left. So I'm just going to shade all this and put a solid arrow on the end to indicate it goes on forever. So notice solutions are any of these numbers I pick. For example, I'll do a quick example. A number that exists in this line would be something like negative 0.5. That's a number that is less than 1, right? It's in my solution set. And that represents my x. So let me check. When x is negative, let me just clear that up a little bit. When x equals negative 0.5, that's a solution. So I'm going to check it so you can see x is negative 0.5. I'm going to substitute that into my inequality, which was x less than 1. So when I substitute this number, negative 0.5, in place of x, let me just clean that up a little bit. I don't know why it's coming out so weird. Hold on. Negative 0.5 less than 1. So you can see this number is less than 1 is correct. It is true. And that's what it means by the solution set. So since we have the inequality less than, there is more than one answer. Versus an equation, you only have one solution, like when x equals 1. But since we're saying numbers less than 1, there's a whole bunch of numbers less than 1. That's why we have to graph the solution set to indicate all the possibilities.